Lesson 96, joint and combined variation, and then more on irrational roots. So this lesson is a recap of stuff we've already learned. Inverse and direct variation is something that we already learned in the past. This is a quick recap. This would be direct variation where P1 goes to A1, P2 to A2. This is indirect or inverse variation where P1 goes to A2 and P2 goes to A1 instead. And then all they're saying here is that if we can combine them, we can actually have three items that are in direct or inverse ratio. Let's find an example and then we'll do it. Okay, here we go. Strawberries vary jointly as plums and tomatoes. Wait, that one's boring. Both. Well, I guess it's a good example. So what they're saying is strawberries vary jointly as plums and tomatoes. So strawberry 1 is equal to plum 1 and tomato 1. And strawberry 2 is equal to plum 2 and tomato 2. That's all that means. Now, let's figure out how to solve it. They tell me that if there were 500 strawberries with 4 plums and 25 tomatoes, so we'll plug this in, 500 strawberries, 4 plums, and 25 tomatoes. They want to know how many plums would go with 40 strawberries and 2 tomatoes. So plums 2 and then 2 tomatoes. So to solve this, we're just going to cross multiply. I get 1,000, because 500 times 2, 1,000, times plums 2 is going to equal 40 times 4 times 25. This is just easier for me to not multiply any of these. Actually, you know what? Whoa, what's 4 times 25? 100, right? 100 times 40, 4,000, equals 4,000. Ha! That wasn't terrible. So 1,000 P sub 2 equals 4,000. Divide each side by 1,000. 4,000 divided by 1,000 is 4. So P2 equals 4. Ha! Found my answer. Ta-da! 4 plums. So that's just joint variation. Same variation problem, but there's 3 items instead of 2. This can also be done inversely. Let's find an inverse one. It says the number of girls varied inversely as the number of boys and directly as the number of teachers. So the way this equation is going to work, girls 1 varies inversely to boys, right? Is that, yeah, yep, inversely is boys. So if girls 1 is on the numerator, then boys 1 is going to be on the denominator, and then they vary directly as teachers. So teachers 1 is in the numerator. So that means girls 2 is going to vary inversely as boys 2, and then teachers 2 will be on the bottom. Cool. So I always draw this chart before I do these so I don't lose track of what number goes where. Now, if they tell me there are 50 girls, so 50 girls, and there were 20 teachers, so 20 goes up here, and then there were 10 boys, so 10 goes down there. How many boys were there when there were 10 girls and 100 teachers? And we want to know how many boys. So same thing, we've got our equation figured out. Going to cross multiply. 100 times 10 is 1,000. 1,000 times 50 is going to be 50,000. So I've got 50,000 equals 10 times 20, which is 200, times boys. Divide each side by 200. Let's see here. Some zeros cancel. 500 divided by 2 is 250. So number of boys is equal to 250. There you go. That's not so terrible. Last part of the lesson of 96 is more on irrational roots. So this is just the lesson 95 that we just did before, where we've got 2 systems of equations like this. I'm writing down the wrong problem. X minus 2y equals 3, and then x times y equals 6. Is this the problem we did from the last lesson? No, it's not, because there was a 6y in that one. So what they're saying is, when you go to solve these equations, sometimes it helps to use quadratic formula. Didn't I do that in the last video? I don't know. Why are they even saying this? I think I did. I don't know. We'll find out. Anyways, To finish this example, I'm going to use substitution. I can solve for x easily because it has a coefficient of 1. So I can rewrite this top equation as x equals 2y plus 3 when I move the negative y to the other side. And then I'll take this value and I'll substitute it in here. So what I have is 2y plus 3 times y equals 6. I'm going to go ahead and distribute. I get 2y squared plus 3y equals 6. I'll set the equation equal to 0, so then I get 2y squared plus 3y minus 6 equals 0. And the lesson would like to point out that it's like almost impossible to factor this perfectly as a trinomial, so you should use quadratic formula to solve it. And that's all they want to tell you. So we're going to use quadratic formula to solve this, and then we're going to get 2 answers. So plug this into a quadratic formula. Negative b is going to be negative 3 plus or minus square root of b squared minus 4 times a times c all over 2 times a. So this first one is going to be, what denominator is going to be 4. So we have negative 3/4, and then plus or minus whatever the determinant comes out to be. So 3 squared is 9. Negative 4 times negative 6 is positive 24. 24 times 2 is 48. So 9 plus 48, which means 57. So square root of 57. So plus or minus square root of 57 over 4. Can that be simplified? No, it can't. All right, so these are our 2 y values. So we would take these into our answers. One is going to be positive 57 over 4. One is going to be negative 3/4 minus root 57 over 4. Now the interesting thing about these problems is when we go to plug them back into the equation, up top we'll plug them into this one since they're an irrational root, is the only number that's actually going to change is the 3/4. So I'll show you what that looks like right here, and we'll do it in orange. So we have x, well actually we'll plug into this equation. So x is equal to 2y plus 3. So 2 times negative 3 over 4 plus square root 57 over 4, and then plus 3. So 2 times this is going to make it negative 6 over 4, and then it'll be plus 2 times root 57 over 4, and then plus 3. So 3 and the 6/4 are going to be like terms. 3 times 4 would give me 12. So 12/4. So 6 plus 12 is going to make it positive 6/4. So for the positive one, I'm going to have positive 6 over 4 plus 2 times the square root of 57 over 4. See? Pretty easy. Now, if we're going to do the minus, you'll notice the only thing that really changed was this and then the 2. The 2 is still going to distribute, so then what we'll get here, we'll still get 6/4, and then but then it'll say minus 2 root 57 over 4. Excuse me. Okay, well, that's it for this lesson. If you have any questions, let me know on Moodle, and I'll see you in class.